is Robin Tatam with Help Systems, and I'm happy to be here to talk to you today about the realities and truth about the exposure of viruses in the IBM world. So I'm the Director of Security Technologies here at Help Systems. My role is really to evangelize the security message, so I do a lot of these types of presentations. Do some services engagements as well, though not as many as I used to, and I'm also one of the SMEs for Commons. So I'll be heading down to New Orleans, another warm place here, in about, I think that's a month and a half, something like that, 2 months. So excited about doing that. I always enjoy Commons, so if you are going, be sure to look up Help Systems. We will be present there. We have a number of speakers as well as a booth in the expo. I'm very happy to have Sandy here with me. We've got some great numbers on the webinar today, and I think that's a direct result of Sandy telling me her fan club was following her here. So Sandy, why don't you introduce yourself, let everybody know what you do for Help Systems.
Hi, thanks Robin. My name's Sandy Moore. I'm a senior technical consultant with Help Systems. I've been working with the products and our customers for over 13 years now, and I've helped a lot of people do software setup and configuration, as well as training, and done some user conference classes as well, and some webinars, and able to share a lot of information with people. It's really important that they hear. So.
Excellent. Well, we appreciate that. We're excited to share in some of your expertise, because I know you're one of several antivirus experts that we have on staff here. Now, along those lines, today's objectives are listed here. We, of course, are going to be talking about viruses, especially as it pertains to the integrated file system where we see most of the risk. We're going to do some comparisons between the Power System and Windows-type viruses and some of the similarities and differences there. We're going to talk about prevention and protection. We're going to talk about a very common approach that people first take when they learn about the possibility of maybe having a virus in their IBM environment, and that's the difference between doing a scan natively, once we understand if that's possible, and possibly just mapping a drive over to the integrated file system and mapping it from a PC. Then we're going to dispel some myths, we're going to give you some facts, and we're going to be happy to answer any questions that you have with regards to antivirus. So Sandy, why don't you talk just for a moment about what the integrated file system is? I think most of us have heard of it at least, but maybe aren't as indoctrinated as perhaps we maybe need to be. I know from my perspective, when the IFS was first introduced back in version 3, the concept, I think, was that it was just an extra file system, but there's a little bit of a misnomer there. So why don't you give us a quick intro here on the IFS?
Yeah, great. Thanks, Robin. So, of course, the integrated file system is your stream input-output storage management system that actually emulates PCs and Unix systems. So what it actually does is provides a structure over all of the information on the Power System. That's all the information on the Power System, not part of it, all of it. And provides a common interface allowing users and as well as applications access to your stream files, database files, documents, and any other object stored in the Power System. And as you said, it was introduced with V3R1, and it makes the Power System so much more accessible and compatible, but it also, unfortunately, exposes the Power System to more potential threats.
And I think one of the challenges there is when the IFS was first introduced and we started including it in our save steps, we noticed it was an extra thing to save. And the reality is if you save the entire integrated file system, you actually get everything. It just makes it really difficult to restore from.
Definitely. So another part, key features of the integrated file system, of course, as it relates to viruses, are the different structures within the IFS. QDLS, which is your document library system, actually supports the folder structure, and it provides access to documents and folders. IBM has actually discouraged people from using that for quite some time, but a lot of customers I've run into still use that heavily because it's been ingrained in some of their processes and they find it's hard to get away from. The root is the actual file system. It is the file system that takes full advantage of your stream file support and directory structure of your entire file system. The QOpenSys is your open systems file system, and it's compatible with the open system standards based on Unix. UDFS, or your user-defined file systems, resides in the auxiliary storage pool or IaaS pool of your choice. And you can create and manage these different file systems however you wish. And QNTC is your net client file system, and QNTC file system provides you access to data and objects that are stored on an integrated X-Series server running Windows NT or Linux. QNTC file system also provides your access to data and objects stored on remote servers running Windows NT, Linux, or i5OS. So you really see a lot of cross-platform integration here when you get into the QNTC file system.
Yep, absolutely.
It also provides, yeah, definitely.
Yeah, the root folder for me is definitely an important one because the IBM I operating system is supplied with a public equivalent of *all on the root file system. So it makes it very easy for anybody who has the ability to map drives to get into that particular structure with enough authority that they can place files out there as well as create directories.
Yep, definitely. So you can see that there's a lot of potential avenues where a virus can get introduced to the IFS. As you said, Robin, with root shipping with *all authority and all of these file systems that are part of that integrated file system so easily accessible, there's a huge window for these viruses to make their way onto your system.
Absolutely. Now, one of the ways that a virus can spread into the operating system environment is through a user map drive or a Windows map drive. This is a particularly easy way of storing or, of course, sharing files to anybody who, in essence, has those types of connections. So in Windows, the typical way to map a drive is to use Windows Explorer. We go in, we choose Tools, we select Map Network Drive, and then for administrative purposes, we may potentially share out the entire file system, which is, of course, not recommended for reasons I already gave. But once that drive is mapped, the actual drive letter can be accessed through browsing. It shows up just as another network drive. So the PC user may not even be aware that they're connected to the IBM I server. They can then save files to the IBM I using that Save As function through any type of application. And in any case, once the drive is actually mapped, if that PC somehow becomes infected, then the virus can spread to the IBM I environment. In essence, any file on a mapped drive is visible to that virus. And bear in mind, any infected file that gets opened by a user is running with the privileges of that user. So if I happen to have all object, for example, then that virus is operating on my system with, in essence, all object authority. Now, a virus is also able to map a drive without our knowledge using the Windows netuse command in a script. Here we can see an example of somebody kind of initiating, in essence, by copying a file to the map drive and overriding that client access setup file. Now, viruses are going to change files potentially for the purpose of spreading to other computers, of course. That's their primary goal. And once they are read by other computers, they can be launched automatically, again, without the user's knowledge. We've had several viruses on customer machines, perhaps, that altered JPEG files, and then when a user uses Internet Explorer to view a web page with that altered JPEG, then the PC becomes infected and the virus is spread to a new host. So we have this propagation of viruses around the network and in the environment. FTP is another possibility. I think a lot of us use FTP for legitimate business purposes, and we have to be cognizant of the fact that moving a file around is definitely a regular source of viruses spreading both to and from the IBM I. Most of us, like I said, are using FTP in some way, either for administrative purposes, for sharing files with business partners, or perhaps even other servers on the network. And unfortunately, the IBM I iteration of the FTP server is going to allow an infected file to both be uploaded and downloaded. From a PC, the put command, for example, executed through a DOS prompt allows a file to be copied, regardless of the content that it has, to any available directory on the integrated file system, even up to the host eventually. Now, the example here on the screen, oh, wrong way, excuse me. No. My WebEx buttons around the wrong way. This one is showing that, again, we've sent a file up to the server, and we, in essence, can infect anything by transferring to that home directory of the IBMI multiple files at once. Another vulnerability of FTP is users saving files using the save as through the software applications. And once an FTP location is defined within that application, we don't have to keep logging in. We're creating potentially a volatile situation because any virus, again, sitting on that PC can take advantage of the connection. Interestingly, if the FTP exec file itself becomes infected, it can start an FTP injection. This is accomplished by a virus actively running in the PC memory and then monitoring for that FTP login and injecting data into the regular flow of FTP traffic, again, without the user's knowledge. And these viruses can easily hop into the FTP traffic, infecting files on any FTP server or, again, on the integrated file system. If you look through McAfee's virus information library, we see an alarming number of FTP-related viruses, and I think that's an area that I think a lot of us are cognizant of, but don't really have good control over. Sandy, there's a number of other avenues, again, that we're introducing viruses, perhaps a little less common than the FTP and in other types of file share connections. But why don't you share with us just some of your experiences of some of the other ways that viruses can bleed into the integrated file system?
Yeah, and you're right, Robin, that they're not as well known and not as common, but unfortunately those are the sneaky ones that can actually cause you a lot of pain because you don't think about those things as often. Your image catalogs, NFS mounts, and UDFS mounts are other ways that viruses can spread between the servers. You know, your image catalog is basically just a file that appears to another system as a CD or a saved large file, and it's often used for loading software. So IBM actually even uses the image catalogs to load Linux on a partition. So it's very common for these to be used. And viruses that have infected a file in these image catalogs or virtual drives will be loadable onto any remote server that uses them. So it really opens up yet another place where data can be shared and viruses right along with it.
Absolutely, and I know from experience, I used to do a lot of OS upgrades and things for customers in a prior life, and certainly image catalogs became the de facto way of doing that so that we could avoid having to load disks throughout the process. So those image catalogs certainly are a common object type in the IBMI environment.
Yeah, surprising one here is client access. No one would think that your green screen session would actually cause you some problems, but client access has actually been a source of virus outbreaks that we've seen personally here at Health Systems. We had a customer contact us about a problem they were having with viruses on their network that kept reinfecting their PCs despite all their cleanup efforts. To make a long story short, the PCs were all running client access, which of course we all do, and the setup file, or the setup.exe file for client access, which is of course located on the IFS, was infected. So each time the PC ran an automatic update, which was every day of course, it would run the setup.exe file on the IFS and start the virus infection all over again. So things pop up in the strangest places. So it's really, you really have to be aware of every part of your system and all the different places that these infections can come from.
Yep, I remember this one, and the customer was very frustrated just based on the fact that they would keep cleansing the clients, and then every time they connect, although they hadn't put two and two together, but every time they connected to the host, they were becoming reinfected again.
Absolutely. And of course, there's your web servers. We have a lot of customers hosting their web pages and their web servers on IBMI, and those web pages are common places where viruses can hide and spread to the PC of anyone who views those pages. And of course, if you think about that one, you're now spreading your lovely virus to all of your customers and partners who are using your website. Viruses can alter the code in the HTML files that redirect a visitor to a different page of the hacker's choosing. So user may think they're coming to your website, but they actually end up getting redirected. It can also insert ActiveX code that will run code on the user's computer. Viruses have even modified the JPEG files to exploit vulnerabilities in Internet Explorer. The net effect is if you have a virus on a web page you're serving on your IBMI and that page is viewed either internally by a customer, business partner, any PC that does come to visit your site can be infected with that virus. Doesn't really harbor good feelings with your customers, unfortunately.
Yeah, exactly. There's lots of ways to get a virus, and I think one of the common responses when I have a conversation with customers about viruses, well, our system isn't connected to the internet, right? I think that's where we see our primary source of risk. But closing off the computer to incoming web traffic is not necessarily going to protect you. It may reduce the risk some, but we have to be realistic that there are other ways to get viruses, and those include, of course, somebody inside the firewall who perhaps is downloading something from the internet. We also have CDs and DVDs. We maybe have USB drives or other removable media that may be the source of an infection. Of course, browsing the internet is a great way of getting your PC infected. That doesn't always require downloading things. It can be happening behind the scenes. We've got laptops, wireless devices, email, of course. Phishing attacks through email have become very much a popular source of malware and viruses. And I think the criminals and the nefarious folks out there who are trying to infect PCs that way have become very sophisticated at managing that and making those PCs look quite, or those emails look quite enticing. If we're doing any kind of file sharing, again, that's another source of infection, regardless of whether your system is actually outward facing to the internet or not. So I know, you know, one of the big questions is, well, how does a Windows virus, for example, affect the IBMI operating system? And here's a few facts for you. Number one, viruses can't hide inside an RPG and CL program. So the native side of the house, when we talk about physical files and programs, are not going to be infected in a traditional sense. Now, bear in mind, you can extend the definition of a virus to be malware and things like that, and I could write, for example, a program that powers down your server and then specify that that's your startup program. So then the system ends up in this endless loop of powering down and coming back up. So while we don't see traditional viruses in that environment, it is still possible to create malicious code. The good news is the IBMI environment isn't susceptible to the traditional sense of a virus because we can't rename objects. We can't make an RPG program look like a physical file or vice versa. So we don't have that rename issue. We also can't embed executable code inside a non-executable object, which is another common source of viruses in the Windows side of the house. As I said, they can't hide inside a physical or a logical file, and the operating system cannot execute a runtime that contains the viruses. However, viruses can hide inside stream files, such as Java and Unix executables, and therefore is potentially going to activate that virus and cause issues potentially all over the system, not just on the IFS side. So when we're talking about infecting the IBMI, it's the ability for that virus to make itself resident on the system, such as modifying files for the purpose primarily of spreading to another host. Here we're talking about how a virus affects the system. Certainly an impact, for example, crashing the server would affect the IBMI as well. We did have a customer who had an infection within their integrated file system that was renaming files as part of its infection. It was spreading. And unfortunately for these folks, they had the root folder shared out. Not recommended, but not uncommon. In one of the directory structures under the root folder is qsys.lib. Now, as I've said, while the infection won't necessarily spread or can't spread to the native objects, it can absolutely impact those objects by either deleting them or renaming them. And there's a number of things that you can delete inside the operating system library that, once gone, will make your system completely unusable to the point where it will crash and you'll have to actually reload it from media. So it doesn't infect the native side of the house, but most certainly can impact the side of the house and quite dramatically as well. Another source here is using embedded SQL. Here's an example of running a command as an SQL statement. That certainly, again, is going to run with the privileges of a user here who has connected to the system to, in this case, just simply send a message through qcommand exec. But it could do other things as well in order to perform more damaging tasks. Perhaps it's a clear lib or delete lib function that would be a lot more damaging than the example we used here. Now, denial of service attack is really something that's going to occur when a virus on an infected host overwhelms the services on the IBMI. That may be FTP, DNS, Telnet, et cetera, et cetera. Now, IBM's documented several APARs, or programming references, that deal with denial of service attacks. Viruses have been known to take down the Telnet server, for example, which in our world is going to have a dramatic impact because most of us are writing our client access sessions and things like that over a Telnet connection. Of course, Telnet goes down, nobody's going to be signing on at that point. Now, the belief that the operating system is immune is, as I've said, outdated and really no longer applies. When IBM designated the integrated file system back in version 3.1, they built this PC-like directory structure over the entire QSys library system, which allows all objects and the system in general to be accessed using industry standard path names. And we see now /qsys.lib, for example, being referenced as the operating system. And that can be accessed. It can even be altered using path names, because to a PC, the QSys library appears just simply as a directory. Now, here on the screen, we can see an example of a PC DOS directory command that lists the contents of the QSys library. And any malicious program running on an administrator's PC, for example, could turn around and delete objects in any library, including QSys or QUseAssist, and as I've mentioned, has the possibility of disabling the operating system. Also at risk is the HTTP server administrative instance, the config files that are stored in QIBM/user data. If you've got a malicious program out there modifying or deleting those files, the HTTP server can be disabled, and that would require a reinstall of that licensed product option. A virus, of course, could also modify the HTML files for the purposes of replicating, so that when someone views those infected pages, as Sandy said, they will also become infected as well. If any of you are using Domino, Lotus Domino on the IBMI, then it's going to store all of its databases in the integrated file system. So those Domino databases, as well as the server code for the Domino server itself, could be damaged by some form of malicious program and, again, require a reinstall. Even if you have antivirus software for Domino, that's not going to prevent malicious code that's running on an administrative client PC from potentially damaging or collecting information from those Domino databases. For those using MQ series, then that application can become damaged by a malicious program again and require a reinstall. So we're starting to see a pattern here that these viruses can absolutely cause infection and damage to the IBMI environment, potentially causing applications to require a reinstall. Some applications, traditional applications, still store data in the IFS. They do a copy to stream file or a copy to import file. That allows us to move that DB2 data from a physical file, for example, store it in the IFS, maybe in a comma-separated value format. That allows us to then open that database up into Microsoft Excel, for example, and access the information directly there, which can be a beneficial business task, but of course, if that IFS stream file becomes infected, then again, when the client PCs connect to open that up, we have that spread of infection moving out everywhere as well. So lots of different ways to spread that infection. So the question becomes, can you prevent viruses? Well, the reality is no. The operating system, the power system that we use, it's not an island. It's not like it was back in 1991 when it was all TwinX and dumb terminals. We have this thing connected, and while it may not be connected directly to the internet, it's typically connected into the server and the network, and that network, of course, is typically going to be connected to the outside world. So through that chain of command, we do eventually have some type of connection. Of course, the network can be the source of those viruses in the first place. Now, if you're using any of the services we see on the slide here, it really opens the door to both the integrated file system, of course, then viruses as well. The only way to truly prevent viruses on the power system is to shut down network services. Not really a step that's practical nor productive. You could go back to SNA and dump terminals again. I did have a customer a couple years ago call me and was talking about their system being hacked. And long story short, we discovered that they were still using TwinX and dump terminals. Again, for most of us in this day and age, not very practical, although it is definitely secure. And of course, we don't allow access to drives or use of wireless devices, which are common access methodologies nowadays. Now, you're probably using some of these common security measures, and unfortunately, not even these will protect the IFS necessarily from viruses. Now, let's take a minute, perhaps, to address firewalls. Relying on firewalls on your power systems for virus protection is kind of like relying on a chain link fence to keep the water out. You feel like you have a solid grid of protection, but you really don't. There's lots of holes there. The bottom line is there isn't any one single solution. There's no way to prevent viruses, only ways to remove them. Now, Sandy, why don't you share some of the things that we can do to protect and to do some cleansing in the virus space?
Yeah, no, I'd love to, Robin. So some of the ways that you can protect against viruses on your power system are, some of them are fairly obvious, and some of them you might not have thought of already. You can use security, of course. Remember, viruses can only spread to files the user has access and authority to. So if the user has an all-object authority, then so does the virus, and therefore can infect all files. I cannot emphasize this enough. If you are signing on and mapping your drives as all object, or you typically sign on with an all object profile, that virus has the keys to your kingdom. And It is so important to make sure that you're not doing that. We actually, I'm going to digress here a moment, had a user with a ransomware virus that managed to infect 500,000 files on their system, and it did actually bring the system to its knees. And they had an all object user with a mapped drive that the PC got infected with that ransomware virus, and it ran for the entire weekend without them realizing. So it's real, and unfortunately that was a really preventable problem because they had that all-object user that they had forgotten about. I digress. You can also shut down unused services. Consider only starting them when you need them and end them when you're done. Do you really need to have FTP running all the time, or do you need to have net server running all the time? Of course, a lot of these are relied on heavily, and you can't necessarily shut them down, but there are some that don't have to be running all the time. And avoid oversharing. You don't need to share root. Very rarely would you actually need to share your root directory. Find the directory that really needs to be shared and just share that individual directory. Perform regular scanning. It's best to automate this process so scanning takes place continuously, automatically. You don't want to rely on someone to remember to do it. You need to make sure that it is part of your process and treat it as you would your backups, taking care of your data and making sure it's there and available for you and usable. Use exit programs to restrict access above and beyond your object security. For example, if you need the FTP service running for back-end processing, does everyone need FTP access? Probably not. Use exit programs to restrict access to your network services like FTP, ODBC, remote commands, and NetServer. So if you're going to do that, you need to audit as well. Audit changes to your IBM folder. Only administrators should be changing files here. For service pack updates might be one reason. Another way is if you suspect a problem, you can track it down to the source. If you're not watching, it's going to be really hard to find, and you don't want to have to go too far back to discover any issues. A lot of times if you wait too long before discovering it, at that point there's really no way to fix the problem that happened. Monitor your scan logs and audit logs. You need to actually deal with those viruses in a timely manner. If you ignore them, they will come back to bite you. Get good backups. Remember, if your IFS has a virus and you're backing them up, your backups are infected too. So you want to make sure that if you're scanning or if you're backing up that IFS, that you're not backing up infected items. Because when you go to restore them, you're not going to have anything to actually restore, unfortunately. So the more protection you have against viruses and malicious programs, the more you're going to reduce your risks. You may have a firewall, mail server, and PC scanning in place, leaving only one last piece of that puzzle to complete protection, the IBMI. It's all about having a layered approach. Today's viruses typically disable the antivirus software running on the PC so it can have free reign over the PC without detection or intervention. Basically, it's poking a hole in your perimeter defenses. So these viruses are free to steal or damage information stored on your IBMI. If you have a native virus scanner on your IBMI, the virus will be met with an unstoppable layer of virus protection, as it's not going to be able to disable it. Any attempts to copy itself to the IBMI will result in immediate quarantine action and alert your system administrator as well.
And I think that's important because I know from my discussions a lot of people say, yeah, but I have antivirus on all of my client PCs, and therefore the IBMI server would never be in a situation where an infected file was reaching out to it. But like you said, a common technique for hackers to use in people creating this type of malicious code is to disable the antivirus engine, which is something that can be definitely done in the Windows world, can't be done in the IBMI world, but you know, of course, if the client becomes infected, then sending that infected file over with the assumption that it could never be there leaves us with a problem. Now, although you can use a PC type of solution to scan the integrated file system, IBM doesn't recommend doing so. Now, if you do use a PC, you got to make sure that you take care of the following steps. You want to set up a dedicated PC for that scan function. You want to map a drive into the root file system, typically with a profile that has all object authority. You, of course, then have to physically secure that PC to make sure that unauthorized access is not happening to the files, because now you've got a root share set up. Typically, it's a read-write share, and it's going to be connected with a profile with the keys to the kingdom. You want to make sure that that PC has internet access in order to download the updated virus signature files, the DAT files. And then you want to make sure that that PC is scanned daily to ensure it's not infected with viruses, to ensure then that when it scans the host that that's a valid scan. You want to implement automated monitoring of the PC to ensure that the IFS scanning is not disrupted. And what we mean by that is it's possible that if a file cannot be scanned for some reason, or if it gets an issue with the actual drive share connection, it may pop up a dialog box, and we need to be ready for that. So you've got to have something to ensure that that interruption doesn't stop the scan. You also want to follow IBM's procedures for scanning the IFS using a PC, and we're going to show you some of the steps to actually accomplish that here. Now, there's a whole bunch of steps. I'm not going to go through each of them individually, but at the end of the day, you can see that these steps are directly from IBM. They're the necessary steps in order to properly scan the IFS if you are using a PC-type solution. You got to follow them in the order. If you don't do step 3, which is going to be on the next slide here, before step 1 and 2, then you're going to have an issue. So everything has to be done in the right sequence here. So a number of things that we've got to do. So not only are we dealing with the disadvantage of scanning from a PC for the reasons given, we have a fairly complex process that we have to follow in order to ensure that this is being done correctly. Now, as I mentioned, leaving a PC signed on with full authority into the root folder, in my opinion, compromises both the security and the integrity of the Power server. Confidential data is now going to be visible on the network because scanning the IFS from a PC requires that all those files are first returned back to the scanning server, and that's going to happen in clear text, no encryption there. The scanning PC itself can infect the IFS with viruses. If you've, again, mapped root folder, the entire Power system is visible to that, as well as a virus or a malicious code. That includes the OS library qsys.lib. Sadly, part of the IFS cannot be scanned. There's a number of problems with PC scanning solutions that can stop the scanning process entirely, as I mentioned. A lost connection, for example, through that drive share. If there's a pop-up type message, or if the PC loses power, of course, all of that scan is going to come screaming to a halt. At the end of the day, this PC-oriented scan is a pretty manual process if you really want to have any chance of removing viruses from the power system server. I don't know about you, but I'm not really up for doing that type of task manually. It's prone to human error, and we really run the risk of not doing a good comprehensive job. There are some performance concerns that we potentially introduce if we're scanning from a PC. Having an increased network load is inevitable because we're bringing all of that data from the IFS back over to the scanning server. We're also unable to use the save changed object command, which in essence saves only objects that have experienced some type of change since the last time they were saved. The reason is that the PC scanning product is going to reset the last access date and time on that particular object. Net effect of that is that all files scanned will then subsequently have to be saved with a save change object, even though the actual file contents have not necessarily changed. It also increases the amount of time because the backups are now going to take longer because, of course, all the objects have been changed or have a non-assigned last change date and are therefore going to be included in the save. Of course, this is all a very slow process because now we're not operating at the bus speed of the server. We're introducing network lag and PC scanning and memory and allocations there on the PC side as well. Now, the good news in all of this is that IBM has done some antivirus enablement of the operating system. So for that reason, the preferred method of scanning the power server is actually to use a native solution to do this. It's more secure, it's far more reliable and stable, and of course, as part of that, it offers much better performance. Sandy, why don't you talk to us a little bit about some of the benefits here of IBM I native scanning, because I think a lot of people are typically unaware that this functionality exists, and it's definitely an important part of the included operating system function.
Yeah, absolutely. So with the native IBM I virus scanning, it does not require a PC or a mount drive with root all object authority, so it takes away that big scary window of opportunity for viruses to get onto the system, even when you're trying to scan and get rid of them. So you're also not going to have data transferred over your network. So that in itself is more secure. You're not actually putting your data in jeopardy traveling across the system or across your network. And then a native solution, of course, is not vulnerable to virus infections because it's not Windows-based. As we talked about before, native IBM I objects, programs, and commands are not vulnerable to those Windows-based viruses because they cannot be executed against. So right there, you actually eliminated that power from those Windows viruses. It's also much more reliable and stable because it's automated. You have your job schedule entries, and you're going to have those run on your schedules that you set up so that you're always going to make sure that it's happening. There's no additional hardware required. You don't have to have a PC that's dedicated in a locked room that's secure but still has access to the internet, etc. This is going to be on your power system, can easily be monitored. Any third-party monitoring tool can monitor the message queues, or a user can just look at the logs and make sure that things are running the way they're supposed to be. And you're going to be able to scan all of the files in the IFS that need to be scanned. It's not going to skip files. It's not going to not know how to pull those files over to that Windows PC. Everything's there. It knows how to handle it. And it's going to be able to detect and remove all viruses. So because it's actually native, it's going to be able to move that file out of the original directory and put it into your quarantine directory. So you're not going to have that moving over. It doesn't increase your network load because you're not actually copying those files down to a PC and then back up again. You're not going to be affecting that. It doesn't reset a file's last access time, which is really important for your backups, of course, as Robin mentioned, and replication as well. So you don't want every time you run a scan to trigger replication of every object in your IFS. It also allows you to do your scanning more frequently because you have that the native running under native jobs, you're going to be able to scan that system, and it's also going to be very fast, which of course is going to help there.
Now, Sandy, one of the things before we jump into the myths and facts here that I think we need to clarify for folks as well, right, is so the infrastructure has been built within IBM. They took care of that back in, starting in version 5.3, and it's been enhanced a couple times since then to the point where they added on-open, on-close type scanning, which really did increase the performance aspect of it here. In essence, IBM provided the car, but they didn't give you the motor inside it. So in essence, because IBM didn't want to get into the antivirus business, they built all of the foundation, they built everything around it, but they didn't provide the actual scan engine. And so they turned to some exit points and system values to be able to invoke a scan engine that you have loaded onto the system. So one of the questions, Sandy, typically is, where does that scan engine come from, right? How do we actually get the scan function that is going to be the native side of that operation? One of the primary sources of that is actually through a help systems application called StanGuard, which in essence is a commercial grade scan engine that plugs into all of the hooks that we've been talking about here in the operating system. Once that scan engine is present, the operating system comes alive, if you will, with regard to antivirus scanning, and is able to actually then activate those on-open, on-scan type functions, the quarantining, the cleansing, using DAT files that are being pulled down from Intel. So very powerful infrastructure provided by IBM as part of the base operating system. The addition of a small scan engine that actually facilitates the actual scanning itself, and you've obliterated a lot of those downsides to doing this type of scan from outside. The other side of this is that not only will it scan IBM, but it can also do AIX and Linux. So if you're using other OSs, such as Lotus Domino, like I said, AIX and Linux, then we're able to actually introduce scan functions into those environments as well. So pretty easy fix, leveraging all of the infrastructure build that IBM has built into the OS. Now, we've got some myths and facts here. First of all, we don't use the integrated file system. I hear that a lot, Sandy. I'm guessing you probably do, too.
Yes.
The reality
it's not as much anymore.
Yeah, the reality is most of us are using it. Even if we don't think we are, the reality is that if we're using client access or TCP itself, for that matter, then we are typically using the integrated file system. Granted, most of the risk is coming from users who have mapped drives. So part of that is potentially the analysis of whether that's being used or not. The other idea is that the power system can't get a virus. Now, the reality is it can host a virus and it can be impacted by a virus. So two of the most important things in that discussion absolutely are applicable to power systems servers as well. So we don't want to fall into this false sense of security that we have an environment that cannot be impacted, because it most certainly can. As I've mentioned, I do hear often, but, we don't use the IFS, or anything that's there isn't really going to bother my native applications. But, of course, if that virus is running with an all-object profile, it can do a delete of a single object in the OS that will crash the server to the point where it has to be booted from media. So definitely something that would be a detriment to most systems. As I mentioned, thinking your system isn't connected to the internet, yeah, it may not be physically connected with a single cable, but it's not an island typically if it's on your network. So the network is connected to the internet, your system's connected to the network, therefore you have some of that risk. Firewall is definitely a benefit, and we want to see those things implemented, but there is no single solution. You want to layer your security functions, be it object-level security, exit programs, antivirus running natively. All of these things work together in order to provide that ring of protection on the system. Of course, as I've said before, the first response is, well, I already have some antivirus solution on a Windows server here on the network. I'll just map a drive into the IFS and I'll scan it from there. But we've seen some of the downsides, both from a performance perspective as well as a risk perspective, that in some instances can actually make that a bigger vulnerability than if you weren't scanning at all, in my opinion. All right, we're going to open it up for questions. We've got the chat window here that you can use if you do have a question. I'm also going to go ahead and open a poll here for everybody just to give us some indication of kind of what you're using the IFS for. We welcome that information. So take a moment and answer that if you would. And like I said, we'll hang out here for a few minutes to answer any questions that you have, and you can use the chat window for that function. Okay, so I have a question here. What antivirus function is there natively if I don't have the Help Systems product? Well, the reality is, like I said, you have the infrastructure. So you have the system values, you have the exit points, you have the object attributes that are on all the stream files indicating whether a scan is required. So all of the moving parts and pieces are there, but the operating system itself is not able to actually perform the scan. It's important to do that with a partner simply because you want your virus signatures to stay current. You want to make sure that it's seeing all the latest risks and vulnerabilities. And that's not something that you want to have against an enterprise server being static. For example, hey, I put an antivirus engine on, but I haven't updated the signatures in 5 years. You're probably not going to be collecting most of the important viruses and the signatures associated with them. So you want to make sure that you add that in. So without the scan engine, the antivirus controls are a good thing to have, but they're not actually benefiting you. All right. Sandy, a question, how does the native scan receive its updates of those signature files?
Yeah, that's a good question. With a native product, such as the Help Systems StandGuard antivirus product, you can use FTP outbound to retrieve those files from McAfee's FTP server. And those files are encrypted, and there is a validation process so you know that they're the correct files so that when they do load into the software, they are validated. So it's a clean way to do that. If you don't have that kind of connectivity from your IBM system, you can use a more manual process by using a PC, download the file, drop it into a mapped drive, and have the software point to that and pick up the new .dat files. So just depends on what your environment looks like, but it is pretty straightforward.
Yep. So at the end of the day, we're actually connecting into a partner of ours because we don't have, a handful of people. McAfee is part of Intel Security. That's their antivirus division. Has over 100 people in a research center kind of managing this and making sure those DAT files stay current. So we want to make sure, like I said, that this is a commercial-grade environment, and sending those files from that environment can be an automated task. So it's pretty seamless, I think, for most people. Somebody here, looks like Mike, asking, in the case of replication, so in this case, having systems that are replicated either by hardware replication or by some type of software solution that is in the marketplace. Any suggestions on ways to purify those objects before that send so that we don't end up with a corrupted backup system in addition potentially to the production?
Yeah, I actually recommend that you run virus scanning on both your target and your production systems, because there's always a window of opportunity for a new virus. So let's say the virus launches into the wild at 10 a.m. You updated your virus definitions at 9 a.m. New virus comes out at 10. It has some time before that virus is identified and new definitions, your definitions are updated and include this new virus. So there is always a window of opportunity for those new viruses to make its way into and infiltrate systems. Yep. So by having the scanning running on both systems, you're ensuring that everything is getting cleaned and that that window is actually closed by doing that. Sure.
Yep, definitely, and I agree. That actually is a good rule of thumb for several things. Exit programs, for example, are a good thing to have on a backup machine, because certainly with duplication of that data going over there, it's just as beneficial for somebody to obtain access to the database on a backup machine as it is for somebody on a production machine. Typically, they're only a few microseconds behind one another, so having that protection in both environments is always beneficial. All right, I don't know about you. I'm not seeing any other questions. Certainly we'll hang for a second if you do want to ask a question. feel free to send that in through the chat window. If not, you can use this email address as well if you'd like more information about the StandGuard antivirus solution, or if you have a question that you were too shy to ask here, feel free to use that email address for that. Otherwise, stop out to helpsystems.com/PowerTech, and you can learn about all of our security solutions for the IBM I and several other platforms as well. Definitely a new space we're getting into, and bringing our expertise to those types of environments as well. See, a few of you still finishing up your survey there, your poll, if you want to wrap that up. I will share with you that 75% of people are using mapped drives, Sandy, so certainly shared and mapped drives are very prevalent. We also have 68% of people that are using the IFS through the application, so using WebSphere or Domino or Client Access, for example. Only 5% said they weren't using it. So definitely a large majority of us are actively using the IFS. When it comes to securing it, 61% of you are using object-level security controls. That's fantastic. If you're getting into IFS stream file security, you're doing really well. It's commonly the most overlooked area of securing the system, but if you're doing that, that's good. 22% of you are using exit programs on the file server exit point. Just be aware that all of the network services like FTP, ODBC, they're all manageable through exit programs and should be. In my opinion, one of the biggest risk areas for data loss is through those network services. Third of the people said not to ask, so we'll pretend we didn't see that, but I'm not surprised. Definitely a lot of people, like I said, overlook the IFS. It's a different world. We don't really understand it. We just hope that it's set up right, and it's a little bit of a shock when we find out that it's not. 57% of you did not know you should be scanning it for viruses, so hopefully you've learned something today that the IFS is very prone to viruses and should be scanned. And 10% are doing it through a map drive, so hopefully you didn't take offense that we railed on that approach a little bit. 10% of you are doing it natively, so we're happy to see that. That's definitely a good step in the right direction. And making sure that the scanning stays active and stays current on the virus signatures, of course, is kind of the icing on the cake to making sure that solution is worth your investment. All right. Well, Sandy, thank you very much. I always appreciate your insight and bringing your fan base and all of your friends and family to these webinars. And I hope to see you again soon. If anybody does have questions after the event, please feel free to use this email address. We'll send out a link to the recording when we're done, and you can always reply to that as well. And we would be happy to answer any security questions or help you with any challenges you have in security on IBM I. Thank you, everybody. I appreciate it, and we'll see you on an upcoming session.